TCP and UDP are layer 4 protocols, transport layer protocols. Now, as data travels down the OSI model, this is the layer at which it's finally chunked up into segments. And we call them segments when it's TCP. We call them datagrams when it's UDP. But anyway, the TCP protocol is used when we're sending things like web pages, files, text, anything where every bit has to be in its place. If a bit is out of place, let's say a bit is missing and all the bits are shifted over one, then you would just get gobbledygook back out, and because the computer doesn't know how to interpret when all the bits are shifted one over. And so that's when we would use TCP. UDP is used for streaming data such as video and voice, where we're interested in just getting it out there as fast as we can. We don't want to wait for acknowledgments and that kind of thing. Let's take a look at the headers for these. So the TCP header is actually 20 bytes long, or 160 bits long. And you can see it's got a source port, a destination port. It has to have those for addressing, so that the receiving computer knows what program to use to interpret it. But it's also got this sequence number, 1, 2, 3, 4, 5, and so on. So that each segment has knows where it belongs in the transmission. It's got an acknowledgement number, so that the receiver can send an acknowledgement back. It's got a bunch of flags and a window size, all this stuff that you don't see in the UDP header. In the UDP header, source and destination, and how long is it? Send it out. That's it. We don't need sequence numbers, acknowledgement numbers, and so on. Let's take a look at some of the differences. TCP is connection oriented. So TCP actually creates a connection before it even begins transmission. That takes some time to do. We call that connection a four-way handshake, or we call at least the procedure for making that connection a four-way handshake, which we'll take up in another video or another time. The guaranteed delivery, so that every bit has to be received as it was intended. If it isn't, then it will be retransmitted. Every segment is acknowledged. That sequence number is checked, and if it's not the next sequence number, then the receiver will send back that it wasn't received. And so then it has to be retransmitted. With UDP, there's no connection made, just send the data. And there's no handshake, it's just best effort delivery. We don't care about any guarantee. There's no acknowledgement, there's no retransmission. If you're watching a movie and that little red dot in the upper corner doesn't appear, or does appear when it's not supposed to, you don't care, because you're probably not even going to see it anyway. And so we send it and we receive it, and that's it. And if it's not received, that's the receiver's problem, not the sender's problem. And the human is really the one generally that notices. Says, oh, my connection is bad on my phone, or this video is pixelating or something. So that's all caught by the human rather than by the computer. Now, all of this is done automatically. We don't have to make that choice. The choice is made at upper layers before that data ever reaches the transport layer. But that's the difference between UDP and TCP.